Are you there? They say the first term of a arithmetic progression. So I know that it's an arithmetic progression. So there is a common difference. Okay? The first term is cos x. The second term, term 2, is cos x. What is it? Plus sin square x. Where x is between 0 and pi radians, the sum of the first 13 terms is 52. Find the possible values of x. Now, the S of n formula is n upon 2a plus n minus, maybe you can put a d in front if you want to. Okay? If you were to complete, that means if you were to go S of 13 equals to 13 upon 2 and our first term is cos x plus, the problem is the d. Then this is going to be 13 minus 1, and that should give you 52. So we need to calculate the d. Our d is normally term 2 minus term 1. You subtract the terms from each other, successive terms from each other. The second term is cos x plus sin square x minus the first term, which is cos x. So basically, the cos x is cancelled. So our d then is sin square x. You get that? So now, it's going to be 13 upon 2, then 2 cos x. It's no need because that is just going to be that now. So I can take that away. It's 2 cos x plus sin square x 12. It's 52. Okay? Let's clean. Maybe multiply both sides by 2. 52 times 2 is 104. 13, that is 2 cos x plus 12 sin square x equals 104. 13 goes there 8 times. So 2 cos x plus 12 sin square x is equal to 8. 8 coming from dividing here by 13 and here by 13. This becomes 12, 1 minus cos square x plus 2 cos x minus 8 equals to 0. Becomes a quadratic. 12 minus 12 cos square x plus 2 cos x minus 8 equals to 0. Minus 12 cos square x plus 2 cos x minus 8 plus 12 equals 0. 12 minus 8 is 4. Minus 12 cos square x plus 2 cos x plus 4 equals to 0. 2 goes here, 2 goes here, 2 goes here, so I'm going to divide both sides by negative 2. Negative here, 6 cos square x plus cos x plus 2 equals to 0. Negative, positive, positive, negative. Positive, negative. 0. You got it? Then let cos x equal to k, 6k squared minus k minus 2 equals to 0. This becomes, if you look for two numbers, it's negative 12, it must be 4 times 3, that is negative, so the negative is on the 4. Minus 4k plus 3k minus 2 is equal to 0. 2k is common here, 2k, then we have got 3k here, minus 2, you also want 3k minus 2, am I right? Are you with me? Plus 1 equals to 0. So far so good. Should I give you an opportunity to have a look? Okay. I'm going to go directly. Maybe I should not do that. For fear of k here is equal to 1 negative, or k here is equal to 2 upon 3. Bring back my cos. Cos x is equal to negative 1 upon 2, or cos x is equal to 2 upon 3. I'm running out of room. Do you get to what I did so far? I'll stand back before I continue for you to have a look. We are not done yet because we are supposed to find the value of x. It's a multi-topic question. These are my type of questions. Are we clear? So I can take away this stuff. At least the first part here, you get to know how I got to that answer. Right, now, the domain is important for me. Nothing to be afraid that I'm going to ask you compound angles here. Okay? So you have got cos x is equal to 1, no, negative a half. Cosine, domain is only up to there, so this is not considered. Negative is here, so this is not considered. So it's pi minus theta. I'm going to come there. Since she says we need to find the inverse, so let's find our reference angle. In terms of radians, please. The interval is given in radians. Give me the answer in radians, please. Thank you. Hurry up. Or cos x equals to 2 over 3. Yeah, what is the answer? 5.3. So our solution will be in the second quadrant, theta equals 2, or x equals to pi minus pi upon 3, that is 3 over 3, that is 2 pi over 3. Final answer, 2 pi over 3. You can give it as a decimal, 0.209, blah, blah, blah. Radians. Give me the reference angle here in terms of radians. 0.841. Good. In this quadrant, the domain is only up to pi radians, so this is scratched out. This one is scratched out. This is the first term, so another answer will be x equals to 0.841 radians. Stop the tape.